Welcome to section 3.4, converting between data types. In this lesson, we'll explore promotions, casting, and converting strings to numbers in Java. Here are your learning objectives. You'll learn about automatic promotions, cautious casting between types, and how to parse strings into numeric values. You've made great progress. As a reward, here's a promotion. Literally, we're talking about promoting smaller data types into larger ones. Let's explore a common pitfall. If both numbers in a division are integers, Java will truncate the decimal before assigning it to a double. In some circumstances, the compiler changes the type of a variable to a type that supports a larger size value. This action is referred to as a promotion. Some promotions are done automatically by the compiler if data would not be lost by doing so. These promotions include if you assign a smaller type on the right of the equal sign to a larger type on the left side of the equal sign. If you assign an integral type to a floating point type because there are no decimal places to lose. Promotion works because the larger type can fully represent all values of the smaller type. For instance, a long can hold every int value. Prior to being assigned to a variable, the result of an equation is placed in a temporary location in memory. The location size is always equal to the size of an int type or the size of the largest data type used in the expression or statement. For example, if your equation multiplies two int types, the container size will be an int type in size, or 32 bits. If the two values that you multiply yield a value that is beyond the scope of an int type, the int value must be truncated to fit the result into the temporary location in memory. This calculation ultimately yields an incorrect answer because the variable for your answer receives a truncated value regardless of the type used for your answer, by the way. To solve this problem, set at least one of the variables in your equation to the long type to ensure the largest possible temporary container size. Integer division may lead to a loss of decimal precision. The same issue occurs with other data types. Prior to being assigned to a variable, the result of an equation is placed in a temporary location in memory. The location size is always equal to the size of the largest data type used in the expression or statement. For example, if your equation divides two int types, the container size will be an int type in size, or 32 bits. Use a double in the operation to preserve decimals. Typecasting is the reverse. When assigning a larger type to a smaller one, or from floating point to integer, you must explicitly cast the value. Typecasting lowers the range of a value, quite literally chopping it down to a smaller size by changing the type of the value, for instance, by converting a long value to an int value. You do this to use methods that accept only certain types as arguments. Then you can assign values to a variable of a smaller data type, or you can save memory. The syntax for typecasting a value is identifier equals, in parentheses, the target type is written, then the value. In the syntax, identifier is the name that you assign to the variable. Value is the value you want to assign to the identifier. The target type in parentheses is the type to which you want to typecast the value. Notice that the target type must be enclosed in parentheses. If you typecast a float or double value with a fractional part to an integral type such as an int, all decimal values are lost. However, this method of typecasting is sometimes useful if you want to truncate the number down to the whole number. For instance, 51.9 becomes 51. The loss of precision with casting can sometimes lead to situations where numbers are truncated, leading to errors in calculations. Casting large longs to ints can cause unexpected values. If the long is too big, Java chops the number and produces a negative result. This behavior, as chopping, comes from exceeding the storage limit of a data type. You'll often see this when casting large values to smaller types. In exercise 1, you'll experiment with casting and observe what happens when values exceed the byte limit or wrap around due to overflow. Consider this background information. It isn't necessary to remember these facts to finish problems. It is more important to understand how to promote end casting. By default, Java promotes smaller types like byte and short to int before operations. It assumes safety by promoting expressions. The Java technology compiler makes certain assumptions when it evaluates expressions. You must understand these assumptions to make the appropriate typecasts or other accommodations. The next few slides give examples. If a byte can't hold the result of adding two ints, Java throws a possible loss of precision error, even if the actual value fits. To fix a possible loss of precision error, you can either declare the variable on the left side, num3, to be a larger data type such as an int, or typecast the right side data type down to match the left side data type. In the slide example, an error occurs because two of the three operands, A and B, are automatically promoted from a short type to an int type before they are added. In the last line, the values of A and B are converted to int types, and the converted values are added to give an int result. Then, the assignment operator attempts to assign the int result to a short variable. However, this assignment is illegal and causes a compiler error. The code example uses principles from this section to calculate a person's age in days and seconds. Because the age seconds variable is declared as long, one of the literal values used as operands in the assigned expression must be initialized as a long value, so that the compiler will allow the assignment. Java promotes any expression containing a double to a floating point result. Use double or cast the expression to an int to avoid errors. If an expression contains a floating point, the entire expression is promoted to a floating point. Just as integral types default to an int, under some circumstances, values assigned to floating point types always default to a double type, unless you specifically state that the value is a float type. This is done by placing a capital F after a number value. Otherwise, 27.9 is assumed to be a double type, and a compiler error occurs because a double type value cannot fit into a float variable. Exercise 2 challenges you to apply casting and promotion rules. Fix the provided errors using what you've learned so far. Java allows you to use underscores in numeric literals for readability. This doesn't affect the value, just makes big numbers easier to read. Sometimes you will need to convert a string like user input into a number. This is especially useful when doing math with text inputs. Converting text to numbers is called parsing. Use integer.parseInt for whole numbers and double.parseDouble for decimals. In exercise 3, part 1, you will declare and initialize strings that represent a shirt price, tax rate, and a string of gibberish. In part 2, parse the shirt price and tax rate to calculate the tax. Then try parsing invalid inputs and observe the resulting errors. If you parse bad input, Java throws a number format exception. This happens when the text can't be converted into a number. Eventually, we'll learn about how to handle this error gracefully. But for now, just know it exists and avoid bad input when possible. To summarize, you've learned how to promote types safely, how to cast between data types, and how to parse strings into numbers.